What's going on, everyone? It's Corbin with World of HVAC, and today I'm going to be showing you the basics of checking a contactor and capacitor inside of a condenser. So the basic tools you're going to need for this job is a meter that will check microfarads, a pair of needle nose that makes just everything easier, and something to take the door off. You're either going to be 5/16 or 1/4 inch. So the first thing you're going to see when you open up the side panel of the condenser is your run capacitor and your contactor. So the contactor is very basic. You have two sides of the contactor. You have your line side, which is going to be your power coming in. You have your load side, which goes to the fan motor and the compressor. And you have your 24-volt connections, which are your thermostat wires that come and make the contactor close. Now the first thing you want to do when you take the cover off is check to make sure that you have no line power, meaning you have no 240, 208 or anything crazy. Obviously nothing is hooked to this condenser, so I have 0. You also want to check to make sure you don't have 24 coming in. You're going to check these two side terminals. That's the easiest way to do it. 0. So my thermostat is not calling at all. Now to find out if the contactor is not working, turn the thermostat on inside, come out and check your side terminals. If you have 24 and it's not on, the contactor is the problem. One thing to check on a contactor are these points. Under this bridge, they are connection points. What happens as that bridge slams closed, you're going to have a little bit of arcing. After 2 to 3 years, you're going to start to create a bunch of carbon deposits. Now those carbon deposits are going to create resistance across that bridge. Those carbon deposits make it fail two ways. One, it will slam closed and weld itself shut. Next thing you know, you got a giant ice block outside. The second way, it will create so much resistance through the carbon deposits that it will slam closed and no power will get through. So nothing will turn on. If you take and you push this bridge in and you don't have continuity, the contactor is the problem. That sound means the contactor worked. You have a couple of things connected to this contactor. You have both of your common leads from the compressor and the fan on one side of the contactor, and then you're going to have the run lead to the compressor on one side, and 9 times out of 10, the run lead on the fan is up here on the terminal with the jumper wire from the contactor. Now replacing any contactor is just like replacing a switch. Mount this sucker right where the old one was, and just go wire for wire. If you do that, you're never going to have a problem cross-wiring anything or blowing anything up. Here's a pro tip if you're working on something that seems really complicated or you're new to the trade and really don't want to mess something up. Take a picture of whatever you're working on, and when you get confused or you need something to reference to, just pull up the picture. You've got the way it was laid out before you touched it. Next up, we have the run capacitor. First things first, make sure you don't have any power to it. Next step is to discharge the capacitor. Now, I've seen a bunch of videos where people will take a screwdriver or a wrench or something and touch a terminal to the case to discharge a capacitor. Don't do that. This is how you really want to discharge a capacitor. You're going to take a resistor and put it across the terminals. If you've ever seen a start capacitor, you see that it has a resistor welded onto it. Lucky for you, a meter has a very powerful resistor inside of it. So all you have to do is touch your terminals together with your test leads. Discharge. Next, you're going to take your needle nose or whatever you want to take those leads off. I prefer needle nose. My fingers don't get pinched, nothing gets cut, and it is super easy. Get all these out the way and switch your meter to microfarads. That symbol right there. Or other meters will just say MFD or something like that. Red and black doesn't matter, it's not polarity sensitive. You're going to take your black one or whatever and go across your common to your hermetic. This is a 48/5 capacitor. We're reading 38.6. And then you're going to go from your common to your fan. This is reading 5. So this capacitor right here is a 40/5 plus or minus 5%. Meaning the lowest you're going to go on the hermetic side is 38, and the lowest you're going to go on the fan side is 4.75. So it's very simple. Just find out 5% of 40 and 5% of 5, subtract it from there, that's your lowest. When you do go to replace a capacitor, most of the time you'll find out that they are different sizes. Not a problem. This particular one is designed to hold smaller capacitors. If you come across a condenser that doesn't hold a smaller capacitor, grab a piece of Kelly strap. You instantly have whatever size you need. So to get this smaller capacitor in, all I'm going to do is take the screw out, Put my new capacitor in, bend the metal. That's it. Of course, the final step is just to connect it. So I have my jumper to my contactor, to my common side, my fan common, my fan run, which is D2 over here. Twist it around a little bit. And my compressor. Goes to hermetic. I hope this helped you out with your problems. If you have any questions, leave a comment down below. I'll be sure to answer them. Please hit the subscribe button to help out the channel. And if you're interested in seeing daily HVAC content, then head on over to my Instagram page where we post constant pictures and constant stories of everything going on in the trade. I've got crazy stuff going on. I've got other people's awesome installs going on. I'll leave a link down in the description, and I'll see you there.